What's up, Internet? It is I again, that guy again, and today we're hacking more Kingdom 1 Hearts Final Mix. And today we're going to go over the entity list, right? Kind of like how that works. We're going to make our own entity viewing thingamajig, and it's going to be pretty cool. Pretty cool. One thing I'll mention is that since last episode in the cheat table itself, I've changed pointer convert to say pointer info, just to make it make more sense, right? But yeah, that's all. So let's take a look, right? So Sora entity. So when we're actually going through and we're looking at the data for Sora's entity, right? In this room, he's the one ending in 7CAO, which previously we found is the first entity in, the entity list, I guess, right? Some rooms it's Sora, some rooms it's something else, depends where you're at, right? But what we're gonna actually do is we're gonna look at the data before the first entity in the game, right? And so if we go back about, let me see, what is this, like 32 bytes? Oops, yeah, 32 bytes. We're gonna see something, right? It's a pointer. It's a pointer to the 7CAO memory address, right? And if we actually go to a different room, look at how the value changes, right? It goes to 0, and then it goes to 1 like CF98CO, right? So if we look at Sora's entity, CF98CO, right? So what's happening here? This is a pointer to Sora. And this CF 7C80 area is actually not where we're pulling our information for Sora's pointer, I guess, right? But we could. It wouldn't break anything. Everything would be the same because it's the same, same data, so to speak. If we go in here, change the pointer, and then just save it, same effect, same thing, right? Recalculate new, change by offset 0. Alright, cool. So yeah, I think this still works, no issues, right? Oh, something broke. I've noticed recalculate new addresses. We just found out live. It might fuck up some symbols. Oh well, just remember your symbols, I guess. So, after seeing that, right, it's 8 bytes for the Sora pointer. There's 16 bytes of nothing, right, which is actually 2 pointers worth, right? Notice how we don't have any party members. Let's try to see, let's turn on warp on unpause, room info. We found out that going to the first level of Alice in Wonderland was what got us the, let's fix that. First level of Alice was what got us the party members last time in the cutscene. Cool, now we have party members. Skip the cutscene. Let's go back and look at our memory view, right? So now we see there's a pointer here, Sora pointer, a pointer here, party member 1, party member 2, right? But then there's a fourth one here, right? And so if we are curious, we'll, right click, and then we'll say find out what writes this address, right? Attach the debugger, turn back our warp cheat, and then we'll warp. Alright, cool, so now we need to find the thing. I hate how it goes away, but it's okay. Alright, cool, so we've got some code that runs. Let's just show the disassembler on it. And so, when we're looking through up here, this is what, accesses it, right? We're moving the value stored in the C register into the memory address that we're looking at, right? And one of the things I see before, now remember the size for the entity structure is 4BO in hex, or 1200 bytes, and we actually see up here where it's basically incrementing RCX by 4BO and storing it in RAX, and then eventually it's moving the value of RAX into RCX if some conditions are met, right? So it's essentially a loop, right? It almost looks to me as if it's putting in here the last value, or the memory address of the last entity in the array. And when we go over here, this actually, yeah, there's some stuff here, and if we go and we say plus 4BO, yeah, I don't know, let's do this. This is the memory address it led to, right? Minus 4BO. Yeah, this looks different. So if we go to plus 4BO, this doesn't look the same as all the other entity data we've seen before. So this must be the end of the structure, basically this, the values the value stored in the address in question is the end of the entity list. So knowing this, right, if we want to go back, let's go back to let's close this out. Let's go and go back to the memory address that we were looking at that stores that info, right? We're going to double click this, copy this address, and then just, send ourselves over there, right? So whenever you resize the window, you got to do it again. It was this one right here, and it leads to CFD100, right? So if we pull out our handy dandy calculator, right, and we go in hex here, and we type in the address it leads to, which is CFD100, and we subtract CF7CAO because that's the start. It's always going to be the start. Gives us this. Divide by 4BO, the size of the structure. There's 12 hex or 18 decimal objects in this room that load, or entities rather, not objects, entities instead. We should say. But yeah, that includes Sora, Donald, Goofy, whatever else it needs to load in for this room. Alright, so now we get into the fun part, which is actually making, the code and all that stuff, right? So what we're going to do is we're going to get this out of the way, hide our calculator for right now, probably minimize this too, and then, so similar vein to how we have pointer info set up, actually going to drag this up, we're going to have to make a group first. And so easiest way to make a group is just make like a dummy, dummy entry, and then just right click, add a new group, and we'll say entity info because that sounds nice. And we do want an address version. Drag it up near the top. And so I'm actually going to go ahead, right click, group config, hide when deactivated. So in our entity info thing here, right, we're going to actually need something to tell us how many entities are actually in the array, entity count, and then we're just going to actually change the address here. We'll say +0 because it's going to be 0 bytes away from the start of our defined memory for the entity info thing. And we're going to paste it. We're going to change count to ID, and this is going to be the one that we want to actually look at, right? Like it's going to ask us which entity from 0 to the number before entity count do you want to see, right? Which entity out of those. And so we'll add 5 to the address because the last one's going to be a 4-byte value. And now we're going to do something where we're going to actually grab the address of the code that we're going to hook at for the function. And so similar to pointer info, right? Because when we went in pointer info, we found a function that got called every frame and didn't seem to interfere with everything, or with anything rather. We're going to actually do this. We're going to, now you would think we would just take the same address, right? But what'll happen is if we use the same address for both, then we can't run them both at the same time, which we may or may not want to. So let's turn on pointer info, see what code it impacts, see some code that we can mess with that's not going to be impacted, like 295E60 instead, right? So we're just going to change the 50 to a 60, and that's going to be our entry point, right? Here, can I just, there we go. Alright, so now we don't need pointer info anymore, we're good. And we're just going to Control A and fix the fact that that's off the screen. Do not like that one bit. Alright, cool. So now let's do our template. We're going to do cheat table framework code, enable disable. We're going to do template injection. We're going to put our fancy E60 area for the jump. And cool, now we've got our base framework. So to start out, we're going to go ahead, we're going to allocate some space, right? And we're going to call this entity info. The amount of space we're going to need, we'll need 4 bytes for the count, 4 bytes for the ID, that's 8 bytes so far. And as far as we're going to go so far, we might go further. We're going to need another 8 bytes for the pointer that's going to store the pointer to the entity itself, right? So yeah, we'll have the count, we'll have the ID, and we'll have that pointer. And I don't think we should need anything else. Yeah, it should be good, should be good. So that's going to be a total of 16 bytes. 4 plus 4 plus 8, if I'm thinking correctly, yep. And we're going to actually just copy paste this part up here. So it puts the 16 bytes or however many we change it to near the area we're injecting code-wise. And then we're going to register symbol entity info. Oops, info. Cool. And then under the disable, we're going to deallocate entity info and unregister symbol entity info, so it cleans itself up. And then inside of new mem, where we're going to actually do our code, we're going to say this, right? So the count is going to go into the first part, the first 4 bytes, the ID, the next 4 bytes, right? The count is going to be more complicated to program than the other one, but let's do this. Let's go ahead, let's preserve the A register so we can use it, and then we'll also use the C register in this. Cool. Alright, so what I think I might do first is the division part, right? Which I'm actually going to have to do a quick refresher on as far as the assembly for that real quick. Okay, I understand division and assembly now. We're also going to have to push RDX as well to do division, because division, apparently what you're going to do is you're going to clear out RDX, right? You don't want anything in there because that's the high set of bytes, right? Unless you do it a different way, but I don't feel like doing it that way, so we're going to do it this way. Assembly's fun, man. But anyway, so we clear out RDX, right? And then we put in RAX the number that we want to, like if it's x divided by y, we put in x basically, right? The dividend, I think it's called. It's a mess, right? Anyway, so we're going to store into racks. We're going to put the number that we want to divide, right? That's actually going to be the number referred to by our new address we're looking at minus the 7CAO address, right? So actually, yeah, let's do this. We're going to, before anything else, we're going to LEA, or load effective address, right? Basically just use the memory address as a value and store it in a register. And we're going to take, it would be, so I have the permanent address down here for like a nearby value. Sometimes it's easier to just take this like permanent address, this offset address, copy it, and then edit it to what you need, right? In this case, we're going to want to take, actually this is the one we want for the LEA instruction. We grab auto assembler again. There it is. Alright, sweet. So we're going to LEA this, and we're going to add the quotation marks to make it pretty for the auto assembler, and then for LEA you have to put brackets around the thing. There we go. Alright, cool. And we also have to tell it what register first. Oops. So we'll use the A register, racks. So now we have that in there. Actually, I'm going to store it in RCX, because in RAX what we're going to do is we're going to move racks, and we're actually going to copy this, but we're going to change something, because it's actually, let's see, this memory address that we want, which is 7C98 according to Cheat Engine, right? So 7C98. So that's going to move the value that we were looking at, in this case the CFD100 pointer down there. It's going to move that into the A register. And so now we can say sub, well, let's see, let's say sub RAX RCX, and that should subtract those and store the difference in the RAX register. But then we're going to have to do our division, and so okay, this will work actually. This is exactly what we want, because then next we're going to move into RCX for BO, which is the size of the entity, right? And then we can say div RCX, and it should store the value we want in the A register. So now we can move into the value stored by entity info. Entity count's the first one. The stuff stored in EAX, because that's a 4-byte value. And actually, with this, we're going to have to do ECX for the div instruction, because that's how that works. There we go. I think that'll work. Yeah, it should work, because the difference will be there, yeah. Okay, cool. Here, let's do this. Move ECX instead. Alright guys, we're making progress. Okay, cool. So now we should have the entity count situated, set up, all that, right? We don't need to write anything in entity ID, but we do need to read things, right? And actually, what we should do, we're going to copy source entity, paste it. Not going to change a thing about it yet, right? And we're going to move it into there at the bottom here. At the bottom here. Come on, there we go. And we're just going to rename it entity, because we already have all the fields we want for entities and checking them and stuff. For the pointer though, we're going to change it. We're going to say +8. There we go. It won't lead to anything just yet. Oh no, there goes our auto assembler. Whatever shall we do? There it is. Okay, so now for getting the entity address itself, right, that's actually going to be pretty easy comparatively speaking. So what we'll do for this is we're actually just going to go and we're going to say, we're going to move into, we may as well use the A register for this. We're going to move into EAX, the value stored at by entity info +4. And that's the entity ID that's provided by the user, which is pretty much just us if we're being honest, but you know. And so after that, we're going to, I think the ECX register actually still has 4BO stored in there. Do we operate off the presumption and just run with it? Yeah, I think we do. I think we do. Okay, so because what we're going to do is we're going to say imul, or multiply, and I'm actually going to refresh my memory on this too real quick. Okay, cool. So in the A register for imul, you have to put like the first value you want to multiply by, which is actually what we're already doing. So theoretically, we should just be able to say imul ECX if the C register still has 4BO, right? And then that'll store in the EAX register the value we get from that, right? So now what we'll do is we'll actually LEA into, well, 7C80. 7C AO is what we need actually. Yeah, we need 7C AO this time. There we go. Alright, cool. So now we have 7C, oh, gotta change that, 7C AO. Alright, so now that's in RCX. And so now simply all we have to do is add the value, add rax RCX, right? And then move into entity info +8, the value stored in rax. And this should work. We'll find out soon. We're going to assign to current cheat table, close this out, and then we're going to scroll all the way down and drag our auto assemble script to the top of entity info. We're going to rename it entity info and call it a day, right? Turn it on, and then change this to entity info. Alright, sick. So it seems like it's working so far. And we can tell because it's actually going through an updating position, right? So let's do this. Let's go back, let's warp, let's teleport ourselves, right? We're going to teleport ourselves, warp on unpause, room info. Let's go back to, where do we want to go today, y'all? Let's go back to Traverse Town. Alright, we're going to pause, we're going to unpause. I don't know if we'll keep Donald and Goofy, we'll find out. We keep Donald and Goofy, so we have broken the shit out of this game because we don't even have fire magic yet. Somehow we've met Donald and Goofy. But something I found earlier, I'll just give you guys the sauce. We're gonna go ahead, we're gonna browse the memory region for Sora, right? And here, let me find where it sent us. Sometimes when you resize the window, it just goes kind of crazy. So in fact, to offset that, right, I'm just gonna copy the memory address here. And then we'll just memory view, big screen it, Control G, and then we can just, so I hit Control C instead, and it copied it. So we're gonna go back. All right, we're going to Control C, not mess up this time. We're gonna hit memory view, make it big screen, Control G, Control V. All right, cool. So you may notice, right, if you're keen-eyed, there's a lot of 83Fs in here, right? And what those mean in float is 1.00, right? So I was playing around with them, right? And I took one of them and I deleted a thing. And the next thing I noticed, and it didn't do anything. Hold up. I clicked a different one and I deleted an 8. There we go. And Sora was transparent. And so then I played around with it a little more, right? And I put like a 0 there. And you can't even see it, but he changed color a little bit, right? Here, actually, let's do 0, 0 there. And like he's got like a yellow tint to him. And if we put him back to, you know, transparent, you can see it better. He's like yellow Sora. But so then I realized like the distance, right? So this is the first value like this. This is the red factor, right? And so we could like put a 1 here and go crazy. Now Sora's like, oh well, no, that didn't even do anything. Weird. I guess that's not how floats work. Let's change this to like an A instead, right? Let's actually just put like FF. Let's go crazy. Oh no, now he's like dark green. Yeah, we've done messed some stuff up. But yeah, so these are the RGB values, right? And or RGBA alpha at the end anyway. So we're gonna bring our calculator back up, right? To find the offset here, we take this address, 9,000, and we subtract the 8F660, right? Oh, gotta be in hex. Minus 8F, gotta hit minus 8F60. It's AO is the offset, right? From entity. So we're gonna go. We'll do it to, should we do it to both? Yeah, may as well. All right, so let's do this. We'll go to entity info, click entity, turn this on. All right, cool. So it's plus AO, right? So we're gonna say plus AO, red, and it's a float. They're all floats. So I just like to do it like that so I can type the offset and just drag it up there, copy paste, change red to blue, adjust by 4, boom, copy paste, change blue to RG. Ah, dude, I fucked up. We fucked up. I'm gonna change this to green. It's RGB, not RBG. All right, copy paste, change green to blue, adjust by 4, bam, copy paste, change blue to alpha, adjust by 4, paste, right? And then we can actually just kind of do this, copy paste, not adjust a thing, because all these offsets are, what would you say, like, you know, they're like plus something, they're not the actual address or anything. And then we just take one of each, take R, G, B, A, and then we'll just drag it off. I wonder, can you drag multiple stuff in? Okay, you can't drag multiple stuff in Cheat Engine, sadly enough. Oh, Nan. Oh, no. Oh, it's because I've like bricked the value because I just started typing stuff in there. That's why. It's not because we messed up the drag and drop process. Here, so actually, something valuable I could do, right? You can just drag them in like that, I guess. I didn't know that, and it like puts it at the end of the stack. That's pretty sick. We're gonna drag him up here, and then we can just, so we got an R and a G. We need a G and an A. Or we got a, I don't even know anymore, man. We're just going through at this point. Drag it in there, drag it in there. All right, RGBA, that's right. All right, let's see how bad Sora's entity is. RGBA. That looks about right. That looks about right. All right, cool. So now we have all that we could ever want, right? We can go in here, we can change this from Nan, we can fix it. We'll set it to 1, 1. You know, all ones is normal Sora. It's happy, healthy Sora. Let's go ahead and move this. We don't really need this anymore. All right, cool. So y'all, we have done it. We have an entity viewer, and we are able to change colors of entities now. Like we're gonna change Sora. He's transparent now, right? We set alpha to 0. We can set it to 0.25 and he's barely visible. You know, 0.75 and he's more visible, but still not quite there, right? If we want to go, say, him to silhouette Sora, silhouette. He's all black. He's nothing, right? I honestly wonder, can you set him to white? Is there like, there's like ultra bright Sora. How crazy can we get with this? How bright can Sora get? Okay, Sora is like deified at this point. Sora is the true Keyblade wielder. He's so bright. Oh goodness. Oh goodness. Oh wow, the lighting does not know how to handle this. He's so bright that he's like glitching out with the lights. I wonder, how bad does this get? Oh, we have Donald and Goofy, but we don't have the power to do, what would you say? Trinities. Oh wow, trippy effects. But yeah, so now let's use our powers. Let's use our powers that we've unlocked, right? Because, you know, we can edit Sora entity, that's cool. But like now we can actually edit entities. And I'll admit, hard thing sometimes is finding out like who's who, which entity's which, right? Sora's entity is 8F60. So if we can find which one of these is 8F60, we can probably find Donald and Goofy next, right? So we'll just go through the list. 8F60 right there. So we'll go to 5. And so this should be Donald, I'm guessing, right? Let's just, boom, invisible Donald, right? Let's set him to like 10 blue. Can we do that? Can we do 10 blue and like, no, anything else? Very sad Donald. Blue and red. Oh, man. Very sad Donald, right? And then the next one's Goofy. So we'll go and we'll say entity ID 6, right? So Goofy. And then we'll just go and we'll change green to like 0 green. Actually, no, mega green Goofy. Mega green. No blue, no red, just green. And then, you know what? We'll go back by 2. So 4 should be Sora. And then we'll go and we'll set him to just full red. Only red Sora. The RGB gang. But yeah, y'all, next episode we're gonna use our, so like last episode we did the short pointers and stuff, right? And so we found out a way for us to be able to, you know, convert those in code or hijack the code to do it for us. And we're gonna use that to be able to manipulate stat pages through our entity viewer next episode. But yeah, anyway, I appreciate y'all's time and hope you have a good one. See ya.